Hello, everyone. My name is Jason Fair, and I'm here with Andy Borka, and we're here to talk about communicating complex visual information via audio for blind flight simulator users. So, the first thing that people are often wonder is, as a blind person, Andy and I are both totally blind, and why would we be interested in flight simulation? Because flight simulation is, inherently a very visual activity. Lots of awesome scenery and various things like that. But there are actually quite a few people that are blind or low vision that are quite interested in this hobby, and the reasons can range from just a general interest in aviation. I mean, most of us have been on airplanes, but you know some people want to know, well, how does this all work? What are the processes and procedures as people are flying? So that's part of it. And the other thing is, people just want to experience what it's like to be in the cockpit of a modern airliner. Several years ago, we could actually do that. We could possibly get, if we asked, we could possibly get into the cockpit of a plane, but that definitely doesn't happen anymore. I'm going to talk a little bit about the history of flight simulation accessibility. And then I'm going to pass it over to Andy, and Andy's going to talk about the Talking Flight Monitor software that we've developed. So a little bit of background. As I said earlier, Andy and I are both totally blind. We've been in the technology field for quite a long time. And for a blind person to use a computer, typically we would be using a piece of software called a screen reader. For Windows, the two major ones are a package called JAWS, JAWS for Windows, or NVDA, non-visual desktop access. And in the most basic terms, a screen reader takes the information that's happening on the computer screen and converts that into audible speech. So if I'm in a Word document, I can, browse around and read. If I can read my email, I can read the web. When we start talking about things like flight simulation, though, we have to do some pretty creative things to make that work. So history of flight simulation. So as far as accessibility, flight simulators are not accessible really in any way. With Microsoft FSX or Lockheed Martin Prepared, you can load up the system and use the screen reader to get the plane, select your aircraft, select your location as far as an airport. But then once the simulation starts, there's really nothing. You can't access the menus, you can't read the gauges, you can't do anything. So what we've needed to do over the years is come up with creative ways of getting access to this information. So the very first piece of software that I was aware of that gave us access to flight simulation was something called FS Navigator. And this was somewhere around 2004. And this gave us access to FS 2004, and I believe one earlier version. Pretty basic. You could control the aircraft autopilot through a moderately accessible interface. It wasn't designed to be accessible, but it just sort of was. And so you could take off, you could fly around. You couldn't really. You could follow a flight plan. If the plan was loaded into your autopilot, and you could maybe land, but probably not. If you were very lucky, you you might be able to land. So in 2010, this is when the sort of fairly large leap forward came in access to flight simulation, and this is a product called It's Your Plane, which was produced by a gentleman in British Columbia, and this was a speech enabled access to flight simulation. So it was all voice activated. And this was really quite amazing for its time. Provided access to many aircraft systems. You could request, request altitude and speed and all kinds of things like that. The problem, though, is that It's Your Plane stopped development, and it was a lot of its features were online. So when the software was shut down, it just went away entirely. You couldn't access it online. You couldn't use it offline because it was dependent on its servers that didn't exist anymore. So that was unfortunate. 2013, we had something called FSX Pilot, which is another piece of software that allows some access to the aircraft autopilot systems, but on again, a fairly limited way. You could fly flight plans. The flight plans that you would use with it are somewhat proprietary, and it didn't actually control the aircraft's built-in autopilot. It actually took over from that aircraft autopilot. The next one that we used up until relatively recently is something called FS-Tramp. And FS-Tramp was a sort of a spin-off from FS Navigator. I believe they used a lot of the same code base. And this was a package that allowed us to do quite a lot. We could somewhat accessibly read airport information. We could read descriptions of SIDS and stars, through the FS-Tramp interface, but it had its share of issues, and so we need another solution. So in 2019, I started developing Talking Flight Monitor, and Andy joined the project in 2020, I believe July of 2020. Talking Flight Monitor honestly started off as a small Python project to see if I could find the closest city to your aircraft and read out using text to speech what it was. That really is all it started as. And it snowballed in an unbelievable hurry. Once the community realized that we could get that information, people started asking, well, can you do this? Can you read altitude? Can you read any other aircraft systems? So Talking Flight Monitor started in May 2019, and it's, as you'll see here very soon, it has grown into something quite huge.
TFM has a bunch of different features. Most of them are either speech-based, braille-based, or audio-based, and we're going to cover some design principles that we have created in order to make these features come into place. The first one is keyboard shortcuts. TFM has over 70 keyboard shortcuts, and these do several different things and are presented in different ways. All TFM features are accessed through these keyboard shortcuts. They're listed in a user interface, so they're easy to reference for the user, or even we need to reference them sometimes. They're global to TFM. This avoids complex navigation issues through different menu systems and different screens. They're consistent. For an example, TFM has two different main hotkeys. One is left TFM, which is the autopilot features TFM. The right side is the main panels or the main instruments that you would access, like altitude, speed, heading. Keep keyboard meaningful for the user. For an example, A generally means altitude, S usually means speed, H heading, and so on. You can easily control altitude, autopilot altitude, speed, and all of its various features with simple keyboard navigation. This translates to group-related UI elements in the same group. For an example, all of the autopilot speed controls are generally located in a single window. Same thing with heading and altitude. Another feature is TFM is self-voicing, which means it puts out speech by itself without the use of a screen reader. This will provide a fail-safe so the user does not lose control of the system even when their accessibility features on their system fail. It prevents critical information from getting lost. For an example, localizer and glide slope, when we're talking about landing in an airplane, is critical. Ground speed is essential for takeoff. FMC messages, which the onboard computer will propagate messages that are critical, that usually indicate misconfiguration or an error somewhere. And it also provides different speech output options for the user, because not everyone may or may not want to use a screen reader. Again, as I said above, the option to use a screen reader, it works with NVDA, non-visual desktop access, JAWS, job access with speech, Windows Narrator, and others that are not more commonly used, such as Ceratec or Nova. The next one, audible and speech output for manual flight controls. It provides a system for the user to be aware of spatial navigation and position. Examples are pitch, altitude, angle, bank. And it provides further customization of output modes. The next slide. Replacement user interface. In some cases, we have to replace the user interface of certain aircraft because they're not accessible. For an example, some of the payware aircraft that we have been working on lately needs a complete accessible redesign. One thing we had to find out is you need to replace the existing inaccessible user interface when a simple keyboard shortcut or joystick button will not suffice. Too many keyboard shortcuts or joystick buttons are required to perform a task. It's impossible to represent the task or job without a user interface. It increases immersion of the game. When designing accessible user interfaces, keep it as close to the original as possible. Mirroring accessible design with an inaccessible user interface allows disabled users to explore other tutorials and how-to guides that other non-disabled people use. Get involved in user groups, forums, or other discussions without modifications.
Just as a quick example of what Andy was talking about, in the 737 and 737 and 777 payware planes that we wrote interfaces for, the flight management computer that we implemented, basically it's using their software development kit. We were able to implement the flight management computer, and our accessible interface is almost identical to the visual interface that somebody would see on screen. It's fully accessible. So somebody can watch a tutorial that talks about how to program the flight management computer, and using our interface, they can mimic exactly what's going on in that YouTube video that's designed for sighted users.
Talking Flight Monitor can be found at www.talkingflightmonitor.com. If you wish to reach us through email, the email address is info@talkingflightmonitor.com. Thank you for joining our presentation. We hope you've enjoyed it.
Thanks a lot, everybody.